Welcome to the evening news. I'm Crash Landon. Today we will be looking at Pre-Calculus Chapter 9.3, the Z-score. If you notice, here on page 458 of Chapter 9.3, we are started off with a load of data. And that data has a mean, or an x-bar, of 7.5. That's the average. And it also has a standard deviation of 2.26, which we learned about last time. Now, if I were to take that data and add 5 to all the data, I would get this new data down in the blue. And that blue has an x-bar, or a mean, of 12.5. Notice it went up by 5. But the standard deviation did not change, because it did not spread the data out. It stayed exactly the same. And with that, I'm going to go on to my correspondent for weather, Miss Old Lady Snuffleupagus Pants.
There's a hurricane coming. Everybody, get in the shelter. It's really windy. Dad, that was part of the plan.
Welcome back. That was quite the hurricane. If you noticed from the last time, when you added 5 to each number, the standard deviation did not change. But if we were to take the same data with the same x-bar and the same standard deviation, and we were to multiply the data by 3, I want you to notice that the x-bar changes by a multiple of 3, but so does the standard deviation, because now we're becoming more spread apart by a multiple of 3. Up next is the correspondent Masky Matilda.
So, sitting around all day has been making people fat. So, if you can't exercise your body, you might as well exercise your brain by doing math. Back to you, Hairy Legs.
Why, thank you. Today we're going to be learning about the Z-score. Now, this is the definition of a Z-score. It is the number we're looking at minus the average, all divided by the standard deviation. Essentially, the Z-score is measured, the deviation of an individual score to the mean in terms of how many standard deviations it is away from the mean. That is, I'm looking at an individual score and how far is it from the middle, the mean, but I do it in terms of the standard deviation. And from now on, we're going to go talk to our economic advisor. His name is one word Pythagoras.
What?
Okay, well, he talked more than he normally does. Well, thank you. What we're going to do now is we're going to go ahead and pass it on to my ex-correspondent. I don't want to be here because my daddy's not funny.
We already did this, apparently, so we're gonna go on to example number 1. If Mary got a 9 on her quiz, and the average is 7, and the standard deviation is 1.5, how many standard deviations away from the mean Z-score was Mary's score? So you take Mary minus the mean, as seen right here, which is 2, or is 9 minus 7, and you divide that 2 by the 1.5, which is the standard deviation, and get 1.3, which is the Z-score. Chris.
Okay! Thank you! Now we're on to example 2, which is on page 460. If you notice that John scores a 79 and the mean is 84, he got a below score. That standard deviation is 4 this time. Therefore, when you do 79, take away 84, and you divide it by 4, you get a z-score of negative 5/4, which is negative 1.25. So John's score is 1.25 standard deviations below the mean, and so